Hi, this is Steve with iFLOW and welcome to our video series. In this segment, I'd like to welcome all Navien wholesalers and contractors. I thank you for joining this session. I'd like to introduce a concept where we take the Navien tankless water heater, which you are familiar with, and we pair it with an iFLOW air handler to create a great HVAC system. I think it's a huge opportunity in North America that especially those of you that are already familiar with the Navien and using the Navien, to be able to now use the Navien as an engine on the HVAC side as well. And we'll introduce the concept, we'll show you why the performance is better than many of the HVAC options that you have now, and why you should consider it as a solution. So thanks for joining, hope you can stick with us. So, we at iFLOW are very excited about the arrival of the A2 and the S2 models. Because of the 15:1 turn down ratio, that's going to give us much lower minimum inputs, which will be great for heating applications. With the MP180 A2 and S2, we've got minimum input of 10,000. For the 210, we've got 12,000. And even for the 240, we've got a minimum input of 13,300, which is going to be excellent for the heating side. Not only the domestic side, but the heating side as well. So why are we excited? Well, Navien already has the most efficient engine at converting gas to heat, right? With the efficiencies at 97, 98, 99%. You cannot get much better than that. But now with the much lower minimum inputs, we can outperform not only the other tankless in the market on the domestic water side, but when we pair it with an iFLOW hydronic air handler, we can actually significantly outperform even the best furnaces in the HVAC market, bar none. And we'll show you how we do that. So don't let the industry silo the Navien into, well, it's just a tankless water heater. It's a heat engine, and it's a great heat engine. And we can apply that wet heat to so many different, in so many different ways, including HVAC, to do forced air. So then you say, well, even better than the best furnaces? How can that be? Well, it's very straightforward. It's not magic, it's mechanics. And we're going to look at that. So first, let's look at the HVAC market a little bit. Heating loads are decreasing. And why? Well, building technology is improving, the insulation is getting better, the windows and doors are tighter. We're using the exterior wraps are getting tighter. The heat loads, and because of that, the heat loads are going way down. The heating equipment also needs to be able to deliver efficiently at not only the maximum, but also at the minimum, right? And throughout the heating season when you need much lower inputs. But unfortunately, the single stage or two stage and even the modulating furnaces are not capable of delivering at those low loads that we're seeing today. So how low are those loads? Well, this is from Natural Resources Canada, and we'll look at some information from the States in the next slide. But this is done by Natural Resources Canada, which is the equivalent of, let's say, the DOE in the US. And they looked at 4 different locations, and they looked at 3 different building types. So basic is standard building code, Energy Star for new homes, which is 20% better than standard, and then R2000 or net zero, which is 50% better than basic building code. And we looked at a number of different cities, so Regina, Calgary, Edmonton, Ottawa, and then Toronto. And you see that for a 1,400 square foot single detached home, on basic standard construction, heat loads less than 30,000 BTUs. And that's on the worst day in January in one of the coldest cities in Canada. So you can see that if you are south of that, it's going to be even lower than that 30,000 BTU. And as you go into Toronto, for example, we see that even on standard building code for a 1,400 square foot single detached, less than 20,000 BTUs. Those are very, very low heat loads. And you know, the days of putting in a 100,000 BTU furnace or an 80,000 BTU furnace, those are long gone. We're way oversizing if we're doing that. And this is the reality of new construction. So let's look at that. So we saw that let's use this 30,000 BTU mark. So let's say that 30,000 BTU, and this is an inverted heating curve, right? So we're looking at July, August, September into December, January, February, March. So this is our coldest, let's say our coldest time. So it's that coldest time of the year that we'll need the 30,000 BTUs, right? 30. But what about in November? What about in October? What about late September? What about in April? What about in May? And we need much less. So luckily this curve is a nice bell-shaped curve, so we can divide it up fairly nicely here, and we see 20,000 BTUs, 15, even 10,000 BTUs. The heating season is identified in this blue square, but all to say we need that 30,000 BTUs in the worst day of January and February. But most of the rest of the time we need much, much less than that. 20,000 BTUs, 15,000 BTUs, 10,000 BTUs. So we need equipment that's going to be able to operate at all of those levels. And when you see this 10, 15, 20, think about the Navien A2 and think about those minimum inputs, right? When we can go down to 10,000 BTUs and not cycle at all, right? 15,000 BTUs, no problem. So this is why we're excited about this when we actually look at the performance of the heating side. So let's look at the US side now. Those were the Canadian numbers. Now let's look at the US side. So this curve is developed. This study was done on a 1,600 square foot home and modeled in 10 different cities across the US, 5 of which were quite cold. We've got Bozeman, Montana, Bismarck, North Dakota, Madison, Wisconsin, Chicago, Albany, and then offset by more moderate climates. We've got Portland, Nashville, Birmingham, Austin, Texas, and then LA. So all to say, when we average those 10 sites together, we were able to develop this curve. And funny enough, you see the majority of the heating falls in this area, where we're between kind of less than 9,000 BTUs up to 24,000 BTUs. So in the colder areas, the curve might shift a little bit to the right. In the warmer areas, a little bit to the left. If it's a bigger house than 1,600 square feet, a little bit to the left. If it's a smaller than 1,600 square foot house, a little bit to the left. Bigger house, a little bit to the right. So all to say, this is representative of, let's say, a number of different areas, all averaged together, but it shows that the heating loads are much, much lower than we expect them to be. Nowhere near 60 or 80 or 100,000 BTUs, right? And this is in the US. So let's look at the furnaces and let's look at what they're delivering so that we can compare to what the Navien and iFLOW offering can deliver. So this is, again, I'm not talking out of school. This is all from the manufacturer's literature and from the Energy Star website. So let's look at Lennox's offering. So they have, this is the #1 highest rated furnace on the Energy Star program at this point. It has an AFUE of 98.7. It comes in 6 models, all Energy Star rated, the smallest model being 66,000 BTUs. Then it says if you purchase the optional iComfort Wi-Fi controller, you can then adjust your unit in 1% increments between 35 and 100%. So to see what that minimum input is, we took the furnaces, so we have 66, 88, 110, 132. Those are the maximum inputs. Multiply it by the 35%, assuming we buy the controller. So then we can modulate down to 23,000 BTUs. So the best furnace on the market in terms of AFUE can only modulate down to 35%, which is 23,000 BTUs. It cannot go below that. So now compare that to 10 or 13,000 BTUs that we can get off the 240A2, for example, or S2. So this is where we're going with it. Now let's look on the Carrier side. Carrier side, the 98.5% is the #2 furnace on the Energy Star program in terms of AFUE ranking. It has 4 models that are Energy Star rated, the smallest being 60,000. So it's 60, 80, 100, 120,000 BTUs. So again, 60,000, and with their patented gas valve, it can modulate in 1% increments between 40 and 100. So you take your maximum input, multiply it by 40, which is the minimum modulation rate, 24,000 BTUs. So these are the top 2 furnaces, and the Lennox can modulate down to 23 on its smallest model, and the Carrier can modulate down to 24,000 on its smallest model. So let's compare those. So a furnace, let's talk about a single stage furnace, 60,000 BTUs. You know it's single stage, it comes on at 1. It fires at maximum and then cycles on and off. So it has a turn down ratio of 1. Only 1 speed. Let's take a 2-stage furnace where stage 1 is at 70%. So maximum would be 60,000. Minimum would be 70% of that, or 42,000, which gives us a turn down ratio of 1.4 to 1. The variable speed modulating furnaces that we just looked at, again, 60,000 BTU, we know that they could modulate, the Carrier one modulated down to 40%, which was 24,000 BTUs, giving us a turn down ratio of 2.5 to 1. Now let's look at the new Navien models. So now we have the 180A, the 180A2 or the S2. Let's assume we're going to do 60,000 BTUs worth of heating with that. The minimum input is 10,000 BTUs, giving us a 6 to 1 turn down ratio. What about the 240? Well, the 240, again, 60,000 BTUs on the heating side, not a problem at all. On the minimum side, we have 13,300, which gives us a 4.5 to 1 turn down ratio. Now let's look at the boiler side. Let's look at the NCB 55, for example. 55, fairly close to 60, so I just put in, it's not 60 exactly, but it gives us a good reference point nonetheless. It's down to 8,000 BTUs, giving us a turn down ratio of 6.9 to 1. So all to say, the minimum inputs on the Navien side, much lower than the furnace side. And on the contracting side, I've talked to so many contractors that think a 2-stage furnace is, a 2-stage furnace with an AFUE of 96, 97 is a great furnace, great option for the homeowner. Well, the numbers don't tell us that. The numbers say that the minimum input is still too high, even on the best modulating furnaces, is still too high for new construction today, or if you're doing a deep retrofit. So let's look at what that means. The 60,000 BTU furnaces are most often supplying more BTUs than are actually needed, especially when we think of the seasonal curve, right? Those 60,000 BTU are what we would need in a house in the middle of January. But what about September, October, November, March, April? So let's assume it's an early October night and we need about 15,000 BTUs in the home. So even with our 60,000 BTU 2-stage furnace, which we saw the minimum input was 42,000 BTUs, right? That's almost 3 times the 15,000 BTUs that we need. So if I'm delivering 3 times the amount of heat when the furnace comes on at even stage 1, then I have no choice but to run 1/3 of the time so that I don't overheat the space, right? If I need 15,000 BTUs and I'm delivering 42,000 or almost 3 times, then I have to cut back and run 1/3 of the time. So it's going to run for 20 minutes of every hour. Now with the thermostat being what it is, it's probably going to be on for 5 minutes, then off for 10, and it's going to do that cycle 4 times each hour. Now what does that mean? Well, I'm coming on for 5 minutes, delivering 42,000 BTUs worth of heat for that 5 minutes, so more heat than I need, and then I'm off for 10. So the temperature is going to go up quickly, and then the furnace is going to go off, and then it's going to drop gradually over that 10 minutes, and then it's going to come on again and heat up 5 minutes quickly, and then down. It means there's a significant variance or stratification from the set point. Whereas, let's look at what we could do with an Navien. If we need 15,000 BTUs, if I'm using an A2 model, even the 240 A2 with a minimum input of 13,300. I can run at 15,000 and run continuously. Just cycle and not cycle on and off, or not cycle on or off at all. Just continually deliver at that 15,000 BTU rate for the entire hour. Not using any more, not using any less, but being super efficient because I'm able to modulate to that lower rate. What does that mean for thermal comfort for the homeowner? Well, I'm not cycling at all. I'm actually just going in and delivering exactly the BTUs that they need into the house, which means our performance line will be very similar to this red line. We're just straddling the set point temperature. This is what we're talking about. Not only efficiency, we're talking about delivering better comfort as well. So when that furnace, right, when we looked here and we're going to be cycling, let's say on for 5, off for 10, cycling 4 times per hour, well, that cycling results in losses, right? Every time the furnace has to shut down, it has to post-purge all of that heat out, and then when it starts up again, it has to heat the heat exchanger again before the blower comes on, so it doesn't deliver cold air into the house. So we see that the lower the heat load, the more the cycling with the furnace because it can't modulate. The more the cycling, the more the losses because every time you cycle, you're wasting heat on the post purge, and then you're using more heat on the startup. So how much more? Well, we've actually modeled this. So this dark gray line represents 4 furnaces. We've got 4 single stage furnaces and then 4 modulating furnaces. All 8 of those furnaces are condensing furnaces with an average AFUE of 92.6. 7 of those 8 furnaces are on the Energy Star program now. Okay. So we didn't know which of those furnaces. Are you going to use the single stage from company 1? Are you going to use the modulating one from company 4? The market will choose. So all we did is we took all of the results and we averaged them. And that is this curve, right? So let's call that the condensing furnace industry curve. What you have in red is the Navien with the iFLOW. And this is the Navien A series, not the A2 series. So the A2 series, the performance would even be better than this. But what we have here is the A model with the iFLOW. So the Navien A model with the iFLOW, and you can see the performance advantage. Now, why is that curve getting wider as we get to the lower BTUs? Right? We've overlaid it with the actual heating distribution from the US houses that we explained earlier. And it makes sense. The lower the input, the more cycling the furnace, the worse the system efficiency is going to be. And that's where the iFLOW and the Navien pick it up because of the lower minimum input capability of the Navien, and when it's paired with the iFLOW, we deliver that performance into the house. So what do we get? Well, we have a 12.5% advantage on this lower end. We have a 5.5% on the higher end, and that makes sense because as we use more and more BTUs, the furnace is going to be cycling less, so it's going to have better performance. So it's going to get better, and the difference is not going to be as extreme, let's say. But nonetheless, we're still outperforming them by 5.5%. And even that, it still never catches us. The Navien and iFLOW still outperform regardless of where it is on the curve. So when we take these two numbers together, because this is the majority of the heating load, we're not going to worry about how it performs at maximum because we're never operating there. We're almost never operating there. We're going to look at where the actual heating load is, and there we can get an average efficiency of 9%. So what this says is the iFLOW and Navien are outperforming the best furnaces in the market by an average of 9%. And again, 7 of those 8 furnaces are presently on the Energy Star program. So here are the results. Here's a summary. So of those 8 furnaces tested, not one of those furnaces outperformed the iFLOW Navien combination system. As I mentioned, we outperformed the average of the 8 furnaces by 9% in the area of the curve where the heating load was highest. And again, I mentioned 7 of those 8 furnaces were Energy Star labeled and are on the program now. So we get this often, right? The furnaces that I use are already Energy Star, you know, they're 98%, 96%. How much better can it really be? Well, we just saw the curve, how much better it can be. You can have a single stage 95% AFUE rated furnace, but we saw the single stage, you're going to be cycling so much more on today's homes that your performance is going to be much, much lower than the 95 stated AFUE or 96% stated AFUE. So don't be misled. AFUE is like quoting, you know, the MPG. If we relate it to a car, it's like quoting the MPG highway for your car when almost all of your driving is done in the city. So we need an MPG city, but that's not given to us in the AFUE ratings. The AFUE does not measure the negative effects on efficiency by cycling. So when we have to deal with those part load heating, and that's the majority of the heating season. It's only really when we're at the peak where we need maximum. The unit does not measure that. So the 96% or 95% that the AFUE quotes is really a fictitious number, unfortunately. And that's why many of the manufacturers use qualifiers like as high as or the potential for savings, because they know it's not going to be operating at that rate much of the time if you actually measure it. But unfortunately, the Energy Star program uses the AFUE as its main determinant. But to kind of solidify that concept, let's look at an example. So if we have, and again, remember that home that we looked at was a 1,600 square foot home. That's what we did the modeling in the US on. If we take that 1,600 square foot home, the heat loss does not change based on the equipment we use, right? The heat loss is calculated based on the insulation we use in the walls, in the ceiling, in the roof, in the attic, the amount of windows we have, so the window to wall ratio and the R value or U values of the windows, etc., and the tightness of the house. That's what determines the heat loss. It's not whether you use a boiler or a water heater or electric or gas. That doesn't change. So hopefully we can agree on that. So the heat loss is the same. So whether we're using a 95% AFUE 60,000 BTU furnace or a 95% AFUE Navien boiler with an iFLOW, right? Both are 95% AFUE rated. Both should perform similarly in this house. Would be the common thought, for example, if we were using AFUE to measure that. The heating curve also doesn't change, right? The seasonality, the fact that we need no heating in July and August, and then as we go into September we'll need a little bit, and then gradually more in October, November, as we saw the curve, and then as we come out of winter into the spring we'll need again less and less BTUs. So that curve doesn't change either. So the heating load in the house doesn't change, the seasonality effect doesn't change. So whatever the heat source, it should be able to deliver comfort and efficiency at those variable loads. So let's look. So based on what we've reviewed thus far, which system do you think would operate more efficiently in a home? And let's look at the 2-stage furnace with minimum input, or stage 1 at 70%. So maximum 60, minimum 42,000. Again, that 1.4 to 1 turn down ratio with an AFUE of 95%. And then we're going to look at the modulating furnace as well, 60,000 BTUs, minimum input 24,000 BTUs. This one is rated at 98.5 right off the Energy Star site. Okay? And then we're going to use the NHB 55 just as an example. And we're just trying to, and the only reason I did this is because the tankless the tankless units don't have an AFUE rating. They have a UEF rating, but the boiler has a UEF, so we're comparing, an AFUE, so we're comparing AFUE to AFUE. So now we're using the NHB 55, close enough to 60,000 that we could say it's equivalent. It has a minimum input of 8,000 BTUs, giving us a 6.9 to 1 turn down ratio, but it also has an AFUE of 95%. So if we're looking only at AFUE, we've got the two-stage furnace at 95, we've got the modulating furnace at 98.5, we have the Navien boiler with the iFLOW at 95%. So conceptually or intuitively perhaps you would say, well, they're all 95 and above. They're all going to be very good performing. They should be great. They should be equivalent. What do you think? Do you think they'll be equivalent? The minimum input of the two-stage furnace, right? The two-stage furnace is 5.25 times higher than the minimum input of the NHB. 5.25. So when we look at that seasonality and the ability to modulate and kind of ride the curve, which one do you think is going to be better? Which one's going to cycle less, much less? The Energy Star labeled one at 98.5 AFUE, right? The minimum input is still 3 times higher than the NHB with the iFLOW. So again, which one's going to be cycling more? Which one's going to be able to deliver exactly the heating that you need into the house? So even though the boiler and the furnaces have the same AFU readings, let's say all above 95%, there is absolutely no question that the Navien NHB with the iFLOW will deliver a much higher thermal efficiency into the house than both of these furnaces by, my estimate, more than 10%. Why? The simple fact that you're going to get all of the gain because of the low modulation rate, that in September, October, November, into December, and then again in March, coming out of February into March and April, where you can just deliver the heating that's needed and not cycle, your efficiency gains will be huge. So even though they have the same AFUE, AFUE does not capture the modulation effect and the negative effect of the cycling that so many furnaces will have. Or when we're comparing which is the better system, this is not included, which is unfortunate because that is the key to the system efficiency, which we saw by the graph of the performance. So it's because that lower minimum input they will be able to deliver with much less on-off cycling, and the less cycling, better efficiency and better comfort for the homeowners. So let's look at the Navien iFLOW combination. So different from any other air handler, right? The iFLOW and the Navien can communicate together. We communicate together to maximize the efficiency and the comfort for the homeowners. So really there are 4 ways that we communicate together. So number 1, the Navien will relate to the iFLOW the inlet temperature, the outlet temperature, and the GPM rate, right? So that's coming from the Navien to the iFLOW. The iFLOW has an outdoor sensor. It's looking at the outdoor sensor, at the outdoor temperature, using its reset curve, and then deciding how many BTUs I need to deliver into the house based on the outdoor reset curve. So then we calculate the temperature that we need, the CFM rate that we're going to deliver, the flow rate, the pump speed, because we control the pump speed from the iFLOW. We calculate that, and then we relay to the Navien, okay, I need this temperature, right? So I need this temperature. The Navien then responds to that request, sends us the temperature we need into the iFLOW, and then we modulate the system to maximize the delta T across the hydronic coil, which delivers the lowest return temperature back to the Navien so it can fully condense. So not only are we delivering the exact BTUs, we are communicating and coordinating on the supply temperature into the primary loop, the CFM rate, GPM rate, and the delta T across the coil, and most of the time we're getting between 45 and 60 degree delta T's across the coil, which is unheard of in the industry. On the low heating loads, right, the Navien, and on loads below the Navien's minimum input, so let's say an 8,000 BTU load or a 6,000 BTU load, the Navien has no choice but to cycle as well. But here's what we do. When we are in a heating call and the Navien needs to cycle off, the iFLOW tells the Navien, hey, we're in a heating call, so I'm going to continue to run my pump. So we continue to flow the pump through the Navien, but we don't fire the burner. And what we do is we scrub all the BTUs out of the Navien heat exchanger, deliver it into the iFLOW heat exchanger, deliver it into the coil, into the house. So we keep the CFM running through the iFLOW, the airflow through the iFLOW delivering into the house, but we scrub all the heat out. So even when the Navien is cycling, we're not wasting all of that heat like we would with the furnace. We're actually recovering it, bringing it into the iFLOW, because we're keeping the pump running, but with the burner off, and then delivering it into the house. And as soon as the temperature is such where the Navien burner can fire up again, it will fire up, start heating the water again, and continue the cycle. So even when we're cycling, we're still maximizing the efficiency by minimizing the losses. The next is we can get domestic hot water priority without the need of a flow switch. The Navien iFLOW communication is such that when we're talking together, we can determine when there's a domestic call and we'll stop the heating. So we prioritize between the two. And then when using the Navien A2 model, the iFLOW can call on the Navien internal pump, deliver the outdoor reset and domestic priority without a flow switch, and all without the need for the Navien H2 Air kit. Right? So this is one of the, with any other air handler, you would need an H2 Air kit to run with that. With the iFLOW Navien, you have a communication cable that does that and takes care of it for you. So these are the things that Navien and iFLOW do together to make the performance. And again, these 2 points are something that no other air handler combination can do, and that's why in all of the testing, the Navien with the iFLOW have come out on top on all, both in Canada and the US, in terms of all the testing that has been done. So can I use any air handler? Well, it should be obvious that if they don't have that communication capability or that functionality, they really won't be able to perform the same. The answer is no. There are certain air handlers that will perform better than others. I can tell you right now, if it's a PSC motor with a 2-row coil or a 3-row coil with no delta T control, no temperature control, no outdoor reset, you are never going to hit anywhere near 90%. I would say you're not even going to hit anywhere near 80%. You're going to be operating in the mid 70s, even with the Navien. As you get into more advanced control, so a constant constant CFM ECM controller with a minimum of a 4-row coil, with integrated delta T control, with pump control. We get into some advanced technology, and I'm not going to go through all of it here, but it's written here. It's on our website if you want to dig into it. All to say that we do have kind of a good, better, best, or what will perform much better. And it ranges, and it can range anywhere from, right, if you have a poor water heater with a poor air handler, you're going to be delivering in that 70% range. But if you have a tier one tankless like the Navien, like the A2s, and paired it with an air handler, with a tier 1 air handler like the iFLOW, we're going to hit the 95 to 98 range without problem every time, bar none, bar none. So this is your range even with the Navien. So let's assume we have a tier 1 system, a tier 1 tankless, but then a tier 3 air handler. You can see the performance can be actually quite low. So don't assume just because you're using the Navien that you will get a great combi system performance. It's not going to happen. And to show that, well, I'll show a couple of examples. One, so we can pick on Renai a little bit. Sorry, we're not pick on Renai. We're not. This is the way the testing went out. So we have we have Aspen and we have high velocity that both tested with the Renai RU160IN. So this is their Sensei model, 160,000 BTUs with, let's say, a Grundfos 1558, and they scored on the Canadian P9, the CSA P9 standard, a 0.72. The Aspen scored a 0.73 with the Renai. So you would say, wow, the Renai didn't perform very well. Well, no. Look at the Renai with the iFLOW. So the same RU160IN tested with the iFLOW with the same Grundfos 1558 scored a 94%. So it says that the Renai wasn't the problem. We scored a 94% with the Renai. We scored a 98% with the Navien, with the A model. But nonetheless, the heat source can actually perform fairly low as well. Now, same heat source, same pump, same testing methodology. What's the difference? It's the air handler. It's the manufacturer of the air handler and the performance that they have in there. So all to say that no, just pairing a unit with the Navien does not necessarily make it such that you'll get a great performing system that's going to be 95% or 98%. No, it's because of what we build into the system. So in conclusion, the Navien iFLOW Combi system the outperformance is not rocket science, right? It's not at all. We're talking about the ability to modulate the burner down to those relatively low inputs, below where the furnaces can, so we minimize the cycling, and that delivers the improved efficiency. It's not rocket science at all. And then the iFLOW, with the unique heat transfer that we have in our coil, with our 1% to 100% modulation capability of the CFM, with our outdoor reset and our delta T control strategy, we're taking the heat that the Navien generates and we're delivering it all into the house. So we're maximizing the efficiency of the air distribution. So pairing these two together create a powerful system. The most comprehensive and fully optimized forced air heating system available on the market today, bar none. So the Navien iFLOW system result in longer run times, right? Using lower inputs and less energy, delivering better temperature consistency, quieter operation because we can modulate down to the minimums that we need, longer life expectancy because the units aren't cycling all the time, they're running continuous, and the continuous operation is the ideal in comfort. So we're giving not only better efficiency to the homeowner, we're delivering better comfort as well. So next step, consider an iFLOW Navien for your next HVAC project. So deliver the endless hot water and the cozy warm homes, all from the best domestic hot water engine and forced air system on the market. It really is the ultimate in efficiency and comfort. So I thank you for your time. If you have any questions on the iFLOW or on the Navien and how we make them work together, here are my contact details. Feel free to reach out. But again, I thank you for your time. Again, we wanted to do this for Navien wholesalers and contractors so that you could understand the power of the Navien heat exchanger and the power of the modulation capability of the new A2 and S2. And when you pair that with the iFLOW, which is the premium air handler out there, you can make a great system that we can perform better than the best HVAC systems in the market without problem. And this is really what I wanted to deliver, the message I wanted to deliver. So I thank you for your time. Again, reach out with any questions and look forward to having you try a Navien iFLOW Combi system on your next HVAC project. Thank you.